Welcome to Steam Powered PD. Today is Friday, April 24th, and I'm here with Alicia Briggs from Lewiston. And could you introduce yourself and tell me what your role is?
Yep. So I'm Alicia Briggs. I am the computer science coordinator for Lewiston Public Schools. I'm the project manager for CS for LPS, computer science for LPS, whose goal is to have every student K-12 in Lewiston Public School have a computer science experience. Kern, please cut my ums out. I'm stumbling.
That's awesome. It's funny. No, it's funny you say that because I'll tell you. So I did this when I do with students. The reason why I go live is not because I care about live at all, but kids will like, look, just keep rolling. Like, don't, and I will. Yeah. I'll start this all over. It doesn't matter. He said, we're just recording right now, so I'll do whatever you want. It's really fine. Yeah, no, it's fine.
Sorry, I've said this 1,000 times, and I stumble over it today. The goal of CS for LPS is computer science for every Lewiston student by 2023.
That's amazing. So talk more about that. That's really incredible.
Yeah, so this is our second year in existence, and we are proud to say that K-7, every student has a minimum 12 weeks computer science education during the school day with classes. At K-6, we do this through STEM class, and at 7-8, we do it in a computer science class. Our primary curriculum right now is code.org, but what we're quickly learning is that the students are outpacing us and they want something new and more and exciting. So next year, we're planning adding more with the Adafruits, the Adafruit Gemma, and exploring that unit in code.org. We have some code combat in there. And our 7th grade teacher is working closely with our 8th grade STEM teacher to see how their curriculum can align a little better so it's not so standalone.
So talk about that. So it sounds like the kids are having a lot of exposure K through 6th or 7th and 8th grade. And then by the time they get to that point, are they kind of outgrowing the code part, or they're just going beyond what's available?
They're going beyond what's available.
Wow, that's great.
Yeah, it's a fantastic problem to have for a program that's so new. Like I said, we just started in 2018, and the kids are they're eating it right up. It's amazing.
So what's your plan then? You said about the Adafruit Gemmas. Is this a case where, I know in our experience I found, and ours wasn't certainly 8th grade level, we're talking more high school level, where when the kids kind of grow out of the, I hate to use this term, but I think this is appropriate, like a cartoony version of coding. Like a lot of the coding that we it's like games. It's just a different version of games. And the kids figure that out, and that's great. But then they outgrow that. Like you said, they kind of like, that's for little kids. And so we went down the path. We've done a couple of things. We've done 3D virtual reality type stuff just because it's just a different medium. It's the same kind of, coding and experiences. It's just a different way to do it. And then also the physical, coding things for the real world, drones or robots, that kind of stuff. So what are you guys finding?
We have a couple different things going. When we're looking at the elementary school, as I mentioned, the computer science education happens during STEM class. And right now the format is they have 2 trimesters of engineering and 1 trimester of computer science. Gotcha. And right now they are all very standalone. There's not a lot of crossover between them. So our first step is to make those units more integrated so there's a better flow to them. And using things, what are my teachers trying? Code.org is a primary curriculum. 6th grade, we started on Code Combat for the precise reason they were kind of getting tired of the cartoony block-based feel. And I'm not going to lie, the first few weeks of Code Combat with 6th graders was tough. Making that switch to text-based coding, they're like, oh, can we go back to the puzzles now?
Yeah. And so it's funny because I've had conversations with quote-unquote real programmers, people that do it for a living, and that is 2 thoughts of this. I have 2, because I code as well, and kind of as a hobby / prosumer, I guess. There is a transition there, jumping from the node-based coding, the graphically oriented one. However, of course, all the logic is very similar, if not the same, and it is good for them to learn new syntax, that kind of stuff. I have been astounded. So we've known Minecraft has been around forever. That's the thing, and it's kind of had a resurgence lately and whatever. So one of the things over this quarantine with my own boys, I knew we wanted to do something that was basically to keep them going and exciting, a little bit creative, but also techie, whatever. So we started our own Minecraft server. They've got friends joining, that kind of stuff. Now my boys were Minecraft experts long ago before me. I had purposely never really dived in hardcore because I knew once I dived in, I would get hooked. I just know, I know myself as the game part of it. But here's the teacher in me, the exciting part about that I pulled away from that is they are doing very serious coding in that. for the stuff they have to do as far as, beyond a certain level. Of course, it's like an open world, you can do anything you want. But if they start doing the redstone stuff, they start to kind of try to code, they're solving real problems. Now it's all virtual, but real problems that they have to figure out the best way and solutions and the best, all that kind of stuff. And I know there was a program at one point at UMO that was connecting Minecraft specifically with coding. And I'm curious, I don't know, going forward, if you see other types of kind of crossover between that cartoony node type of coding and quote unquote real coding, text-based stuff.
We did have an interesting example with Minecraft at our high school. We have one intro to programming class, and new teacher, we had previously had a license to Minecraft for education from the former computer science teacher. And so we got the kids logged into that, and they didn't really take to it that much. We were really surprised. Like similar to Code Combat, once they really had to work and think, and they couldn't just play in Minecraft all class.
Yeah.
So one of the solutions we found was Microsoft's Make Code. I don't know if you've seen that one.
I have, yeah.
And that hooked our ninth graders, high school's 9th and 10th graders right away. I wouldn't say it's as much real world problem solving, but the fact that they were given the foundation for a game and then could modify it and create it as they wanted to, by the end of the semester, they were making some really complex games and were getting frustrated with Make Code because they couldn't do all the complexities that they wanted it to.
That's been really interesting to me, watching, again, my own boys and their friends, right? So none of these kids would call themselves coders. Now, what does that mean today? Who knows? But they would consider themselves that as a hobby, or they just playing this game. And they have a problem to solve, and they'll go find their own resources. They'll look on YouTube or whatever it is to go find that thing to solve this problem. And these problems, if you broke it down like on paper and pen, they're very complex. But because they're in that world, because they're already in that mindset of like, well, I know I have one block and I push this block, whatever, like they already know the limitations built into it. The workarounds they do are just astounding.
Right?
Yeah, they're crazy. They really are. And so I can totally see, I just, think of it as a generational thing, where if there is an entire generation of children who have that just as a baseline, as far as like, you and I had the radio going in the background, whatever, things that we just kind of took as, for granted, or the internet, whatever. But if we knew that, pretty much 85 to 90% of the kids have experienced this in some capacity. So if I said, oh yeah, that's like a redstone switch or whatever, that translates to this, and they can make those links. That means like, that's amazing. That really is.
And that's something we've been working on. It's really kept the core of us, I think, centered during quarantine. The STEM teachers and the 7th grade computer science teacher were all taking an online course through University of California, San Diego, which is called Computational Thinking for Everyone. And it's best practices on how do you teach essentially block-based coding in a K-12 environment. But for the teachers, it's really been their first deep dive into not just what these coding concepts are, like you think of loops and if statements and whiles and all that. It's the research-based, this is the best way to teach it to students so all students understand it, not just the ones who typically do. And what's been neat while taking this class during quarantine is that the teachers are diving into it 110% and talking about how they want to adjust their curriculum next year so we can better meet the needs of what block-based coding was for. It doesn't matter what language you're doing, you're still getting the fundamentals of it.
Sure.
So their latest idea. Sorry, go ahead.
No, I was curious how is the besides your teachers, how has the quarantine affected your students? Are they still doing work, or are they kind of just doing stuff on their own, or as far as that goes?
It depends on school by school. So we broke our quarantine plans into 3 phases, and the first 2 phases, which are going, phase 2 is going to end next week, I think. We're really making sure that we had nutrition pickup points established, getting food out to our families. The last 2 weeks were spent getting technology into the hands of our families who may not have it at home. And now that that's pretty much squared away, we're moving into phase 3. And so for our elementary students, they have expectations with math and literacy. And the unified arts, which is where STEM would fall under, is going to provide a week's worth of activities, and that rotates each week between schools.
Gotcha.
So given, yes, they have access to the technology at home, we might use some of our online platforms, but I have a hunch we're probably going to lean more towards the engineering, building a bridge at home, those kinds of activities. On the other hand, though, we have our Hour of Code sites up and running, a couple other online activities that we've curated over the years. And we're starting to see an increase now that technology's out in the hands of students, of more students just visiting our cs4lps.org website, clicking around, playing through. And similar to 7th grade, students are using, I think it's code.org's app lab, and just taking the skills they learned from Miss Avery's class and having fun with it.
Yeah, that's great. Again, once you get that little bit of hook, once they've decided like, wait, this is fun, I can do, again, and I've seen that, you see the younger kids with some of the game/codes, and as long as it translates, it's great. And we've done, like I said, and I'm not sure where to go forward here, as far as like we have the physical components where we're coding, but we're doing like robotics, we're doing physical things, and of course that's a great hook in the sense that they can code something here, see the results immediately, not in the real world. And so one of my hopes is to do some telepresence type stuff where kids are coding on their end, they're controlling robots here at my house, but I'll just have cameras on them. Yeah, so we've done it before. We always have at the end of the year, we have kind of like a battle bot thing where kids build robots and they kind of compete against each other or whatever. And last few years, Keith and I have done where we've had basically the cameras on the whole arena, for lack of a better term. But the kids that are running it are actually in different rooms, or we had a couple times within different states. We had people invite them to join us, whatever. And of course there's lag. And what we discuss about that is like, if you're controlling the Mars rover, guess what? You have lag. Like you have to deal with, how do I move this here and wait 13 minutes later for it to actually move, there? So those kind of experiences that are a little bit real world, but they can kind of watch in real time and have fun with them. So I don't know, we're going to try to figure something out with that.
Yeah. No, and we've been thinking about that too. As I said, we're in the process of revamping our curriculum now as we learn more. How do we make this more project-based learning so that the students can demonstrate what they know and not just have to take a test, which we all know the benefits of that. But what does that look like in a remote learning setting? I have no idea.
And even like, like you said, like materials, like how does that scale? Like, we ship them a box that has a bunch of little stuff in it and they can build or work, or I don't know. And we've had the same discussions, but I'm not sure yet either.
And you think of even just the cost of some of these things. Like I would love to ship Ozobots to all of our students, but those are like $100 a piece. It's really challenging.
Well, I've had this discussion with a couple of the tech directors too from different districts, like, and other educators from different states, because Maine has had the culture of sending machines home before this, Milty and middle school level, high school, and so forth. When it came time to send, even younger students home with devices or send them home, it wasn't quite as the hurdle. There was still some pushback initially, like, oh no, what happens if somebody, whatever, but that was very quickly, overrun with like, what, we just got to do this. It's more important. And I wonder too, talking to different educators from different states, like there was still like, oh my goodness, you can't send middle school kids home with devices, they'll destroy them or whatever. And we've kind of hopefully, just blew by that.
Right. No, but I keep, sorry, I'm still dwelling on your idea from a couple minutes ago with the battle bots. Like that would be so neat if you had one person stationed with all the robotics, say Ozobots, Legos, whatever it is, the kids send you their code, you load it, and then you have a live stream of it. That could...
So we're going to do that. We're going to do that. I haven't done it yet to know exactly what it's going to look like, but we would, the state student conference is going to still run virtually in May, and my option to offer was to try to do a telepresence, robotic competition of some kind. And I don't, again, know exactly what that looks like. We'll have to test it first. But my vision is that kids would work in teams. They would have, shared docs or something to be able to, work on code together. That they would actually, we'd have different machines locally that they would either use Chrome Remote Desktop or something like that. So they're actually on the machine. We're using they're there. They're using Sam Labs. The reason why I like Sam Labs is just because it's easy as far as the code is all drag and drop. It's all web-based. They can use Workbench EDU to run it and that kind of stuff. They can share between, of course, is the realities of, in the room, you can like make adjustments physically because you need to. But I don't know. We'll figure that out. I still think it'll be valuable, worthwhile.
Yeah, you do what you can. I mean, that idea alone, even just a simple concept, that's great. I love it. Sign my students up.
Well, let's plan on, maybe we'll do a test run ahead of time, like use some of your kids against our kids, just to do a test run to see what it looks like, just to work out the bugs.
Absolutely.
Yeah, that'd be fun.
Let me just volunteer my students. That's what we do. You're doing this.
Well, I told my kids, so my students I have in my STEAM class, I said, look, guys, I'm going to be mailing you kits of robotics, so they'd have their own to play with, and they've been using them in school. But now I said, look, I'll just mail you a kit and you have it, and we can go from there. And I asked my wife, who's a physician, said, is this okay as far as like, is there any issues, medically, whatever? She said, no, it's fine. Like, if you mail them, they'll be fine. So that's the plan. But maybe it'll be better to have them just do it virtually together. All we can join other schools together and do that. It'd be fun.
I love that.
Yeah. Awesome.
And on the teachers, sorry, go ahead.
Go for it.
I would say for the teacher side, it's been fun for us too. Like, yes, we have our little cohort taking this class, but we also opened up some of our online content that we internally were testing. And we just said to any teacher, hey, if you want to try this out while you're home, be our guest. And what's been really exciting for me in particular is the number of high school teachers who are starting to teach themselves coding using our content. I'm like, ooh, what can I do with you in the fall or winter?
Yeah, we had some success. So the theme class I have, which was more engineering based, like you're saying, kind of, and people asked, so the kids were asked, well, is this a coding class per se? I said, only if it needs to be. Whatever we need to use to accomplish the goal. And so our first project has been, and again, we kind of got cut short, but our first project was the kids wanted to make what we called a tabletop Roomba. And the idea was it was to help the lunch, custodians, lunchtime, to clean the tables. They'd set a robot on the top of it, hit a button, it would clean the top, and then stop when it was done and beep or something like that. So there's a lot of components to that. Yes, there's coding, there's 3D printing because we have custom chassis, there's robotics, you have to make sure that stuff works, all these different pieces. And they were working away and it was going fine. And so that kind of idea of having so we talked with one of the teachers, one of the language arts teachers, and she's like, that sounds really good. She's having her kids research real projects and, that they can help with in the world or whatever. Now they're doing the research component of it, but she's like, you know what, when we're done, we should come down to the STEAM lab and build these things. Like, actually, if you come up with an idea, let's go do it. And that, to me, it's almost required, because it's great to think about an idea, but that's the easy part. I have an idea. Okay, let's go do it. Let's go figure out what it really looks like.
Yeah, it's similar. We're just getting some momentum going with our Q robots before school ended. And one of the projects we had done, we have a phenomenal tech integrator at the middle school. Her name's Dr. Sarah Irish. And she developed a lesson that meets math and ELA Common Core standards, along with CSTA standards. Where students read If You Give a Moose a Muffin, and then they have to program the Q robot to go get all the items in order. It was adorable. But one of the students, it's like, well, we just kind of drive over the piece of paper of the item. It would be really cool if we had the actual item to pick up. Right. And Sarah and I look at each other, it's like, yeah, but the robotic arm attachments to the cues are kind of expensive. And then we open that up to another student, and they just built us an arm out of that goes for the cues. And we were just starting to think about how can we 3D print the physical items to make this lesson even more enriching.
Yeah, and that's where, like, we get to the point where we are either there or getting there very quickly. Like, you throw a 3D printer, you throw a little coding, you throw a little, VR, robotics, like these baseline things, like not specialized things, but pretty generic tools that the kids can start. Like, what problem do you solve? Let's start throwing these things together and make this thing out of it. The thing I got a kick out of one of the students, one of the girls, was very much into the graphic design of this robot. And it was going to be the ladybot instead of a ladybug. It was going to look like a ladybug, and she wanted to go, all these different things, whatever. And it reminded me. So when I showed them at the beginning of the year, there's a great Netflix series called Abstract.
Yes, it's so good.
It has all kinds of different topics, but one specifically, they talk about the MIT Media Lab. And one thing they talk about is how whatever work they do when they're done, it should be able to appear on, Art Weekly, cover, as well as Nature, as far as like it's using both of these kind of things and kind of putting them together. And that's really when we get the kids to that point where they're naturally pulling these, different content areas and different ideas and all this stuff to build whatever they need to do. But they just naturally bring these things together and kind of, the synergy around that. I think we can.
Right. And I'm fortunate in Lewiston, given my role in that we have a technology integrator for every grade span, that while the students are often running with these ideas, we can take a step back and say, okay, we're meeting these Common Core math standards, this NGSS phenomena. So when we're trying to bring more teachers into the fold, it's not the scary STEM computer science thing. It's, look, your students are meeting the same standards you're already teaching. It's just a little bit different than what you're used to.
Right. Absolutely. Well, and I think the silver lining that I'm taking from what we're the situation we're in right now is, regardless of anything time that's spent right now doing these things, it's not time wasted. Like, it's
exactly
you're learning your skill set, you're getting more things. And I think it's hopefully, I have found like the issue hasn't been the students instead of tech wise, like they're fine. It's getting some of the, educators caught up to where they need to be. And I like going forward, that should be the baseline. Like you gotta be at least as, know what the kids need and be able to be there for them. And I think it will. I think this has really been an eye opener in that regard.
Right. I think we're going to hear a lot less of, well, I don't need a computer to do this. And
no, exactly. I think, yeah, exactly. It's not a panacea. It's not an end all, but it is certainly like, there's certain levels of what you need to know just to function with the students and through the day and what they need. And we're finding that. And so it's been interesting, and I'm sure we'll, continue to be going forward. So.
Right.
Well, I really appreciate your time. Thank you. I think hopefully things are going well for you as they can. I know April vacation, we're all home. So yeah. What are you going to do? But I think that's a great place to stop. I'll stop the recording.
Okay, excellent.